How exciting is this? Oh, we've gone a long way. From battling to get our images into tensors, our labels into tensors, preparing our data, choosing a model on TensorFlow Hub, creating model callbacks. We're finally at the stage where we're ready to train our first deep learning model. So let's create a heading, training a model. Now we're going to put on a subset of data because if you remember back when we split our data up, we're only going to start training on 1,000 images. Because why do we want to do that? So let's write here, our first model is only going to train on 1,000 images to make sure everything is working. So that's what we're trying to do. We're trying to minimize our time between experiments. So we begin by starting on a subset of the data to make sure all of this code, it might break, right? So we want to make sure that it's working before we spend a long time training on 10,000 images. Because training on 1,000 images is going to go a lot faster than 10,000 images. And you could imagine the same goes if you increased it to 100,000 images, or in the case of ImageNet, 14.2 million. So there's one more variable that we have to define before we can get into training a model, and that is number of epochs. And so the number of epochs is how many passes of the data we'd like our model to do. And a pass is, you can imagine, is equivalent to our model trying to find patterns in each dog image and see which patterns relate to each label. Let's go into here, num epochs equals 100, and we're going to do something cool here. We're going to create a little slider like we have before, param, and then we're going to create type slider, and then the min will be 10, the max can be 100, and then the step can be 10. Look at that, how cool is that? So if we wanted to do 10 epochs, we could do 10, but we're going to stick it to 100 because we've got our early stopping callback. And we're going to see all of this in action in a second. But essentially what a training pass is going to do, if we go back to our keynote, one epoch would be giving our model a single chance to look at all of the training data and then validating it from there. 100 epochs, so we're giving our model up to 100 chances to go through the training data set and figure out the patterns. So it's going to, what a pass is, it's going to go through these layers. We're going to pass our training images to our model. It's going to go through these layers. And then our model, as it learns patterns, is going to make guesses on which label belongs to which image. And the worse off the guess is, the higher the loss will be. So that's where Adam comes in. Remember that guy down the bottom of the hill at the International Hill Descent Championships is telling our model how it can improve its guesses with each epoch. And then we're going to see how our model is doing on an accuracy level because we've got that spectator judge at the bottom of the hill watching how well our model is performing. So again, if all this doesn't make sense, it's going to make more sense once we actually start to run a model. So let's do one final check. The final check is one last time to make sure we're using a GPU. Because if we're not using a GPU, this training our model on images is going to take a very, very long time. You saw right at the beginning, a GPU can speed up our code by up to 30 times and sometimes more. Let's write that code. Check to make sure we're still running on a GPU. So print GPU available. And then we're going to go, yes, if tf.config.list physical devices, and then we want to check GPU, else not available. So this is just the same code we wrote above, but we need a GPU to be able to run this in a considerable amount of time. Yes! We could also have checked here. Remember, that's a little shortcut trick, but I love seeing this print out here. Now, boom, we've got a GPU running, we've got number of epochs set up. Let's create a simple function which trains a model. So let's write that here. let's create a function which trains a model. And the function is going to create a model using create model. And then we want to go set up a TensorBoard callback using our TensorBoard function. So create, see, this is where creating functions has really come into play for us here. Otherwise, we'd have to be writing code ad hoc, but writing functions to begin with takes a little longer, but in the long run, saves us time. So call the fit function on our model, passing it the training data, validation data, number of epochs to train for, which is num epochs. We just define that with our sick little slider. And the callbacks, which are our helper functions, we'd like to use. And then finally, we want it to return the model. We're going to change this into Markdown. That is looking phenomenal. Okay, let's go here. Build a function to train and return a trained model. So here we are, def train model. I can't believe we're finally up to this. This is amazing. We're training our first deep learning and neural network. So trains a given model and returns the trained version. Nice and simple. Remember, even though we're getting excited, doesn't mean that we're losing our communicative habits. So we'll create a model. So we'll go model equals. See, this is where our create model function comes in. Oh yeah, that's so satisfying to write. And then we go create new TensorBoard session every time we train a model. Because remember, with our TensorBoard callback, we'll just call this TensorBoard. We don't need the callback there. We set up our function. So if we come back up here, every time it's called, it's going to create a new folder in logs with the current date time. So this is important because every time we run our train model function, so every time we try to train a new model, a new experiment, we're creating a logs folder, which we can then track our model's performance. So that's a real helpful thing later on when we're trying to evaluate which experiment did better than another. And then we go fit the model to the data, passing it the callbacks we created. Now again, there's probably a better way to do this function, but we're just trying to make it so that it works, and then we can go back after we've sort of got through the phase of fitting a model for the first time and refine it. So let's go model.fit, and we're going to pass it x equals the train data, which is a data batch, if you remember, which contains the images and labels. So epochs is going to be num epochs, aka how many times is our model allowed to look at the training data before it stops? Or how many chances did our model have to pass over the entire training data set to find patterns? And then the validation data is going to be val data, which is a data bunch as well, or a data batch, sorry. And the validation frequency is how often we want to test the patterns that our model has found on our validation set. And we set it to 1 because we want it to test its patterns that it's found in the training set on the validation data every epoch, so once an epoch. And then our callbacks are TensorBoard, which we've just created above with our function, and early stopping. Whew! And then we want to return model. Put a little return the fitted model. How cool is that? And now we can fit our model to the data by as simple as going model equals train model. You see the benefits in creating functions? So we could run this function after doing a bunch of different experiments later on. And so are you ready? Now, a little tidbit here. When training a model for the first time, especially on image data or any other kind of large-scale data, the first epoch will usually take the longest compared to the rest. Now, this is because the functions that we've written is getting the data and it's been initialized. So aka loading the data into the memory of our GPU. Now, using more data will generally take longer, which is why we've started with 1,000 images. And so after the first epoch, right, we've set it up so that it's capped at 100. The first one might take a couple of minutes. After the first epoch, subsequent epochs should only take a couple of seconds. So you ready? We're going to do this together. Fingers crossed, all of our functions, because this actually depends on a fair few lines of code up here. Let's see if it works. 3, 2, 1. Oh, look at that. Building a model with MobileNet v2. I got my fingers crossed. I hope you do too. Yes! It's starting up. See, there we go. Epoch 1 of 100. Because epochs is set to 100. So it's going to train for 25 steps, which means our batch size. So if we have 800 images in our training set, because remember we started with 1,000. So if we divide that by 32, we get 25. So that's why training is 25 steps, because there's batch size 32. And validation, if we go 200 divided by 32, it's going to round it up. So it's rounded it up to 7. That's why we have validation. So 200 images over a batch size of 32. And check this out. There we go. ETA, about 5 minutes. And so here's what I'm talking about with the loss. So now all these things that we created right up here, so the loss, so our goal is, remember, to minimize the loss. Because we're at the top of the hill, we're afraid of heights. We want to get to the bottom of the hill. You want to minimize the loss function. The loss is the height of the hill. We come down here. So hopefully this number goes down, but we want to maximize accuracy. So that's how we'll know if our model is training or not. If it's learning patterns, this loss should go down and this accuracy should go up. So this is going to take a few minutes to get through the first epoch. I'm going to wait until it's gone through the first epoch, and then, so I'll speed this video up, and then I'll see you once it's past the first epoch, because you're going to see subsequent epochs after this. So epoch 2 out of 100 is going to be pretty quick because we're using a GPU. The only reason the first one takes a while is because it has to load all of those images into the GPU memory. I'll see you pretty instantaneously, but for me it'll be about 3 minutes. Alrighty, I'm back. So we've got an ETA here, which stands for estimated time of arrival. There's about 12 seconds left in this first epoch, as long as everything goes to plan. And so you can see the loss has reduced slightly and the accuracy has increased. So this is a good thing. Now what we should see at the end of this first epoch, if we set it up correctly, we should see, this is loss on the training set and accuracy on the training set. We should see the loss on the validation data and the accuracy on the validation set pop up any second now. So we're just waiting. So probably what it's doing now is it's been a little bit longer than 12 seconds, but it's loading the validation data into memory so it can calculate and evaluate how it's performing on that data set. I can't believe we're doing this. We're like training a model together in real time. This is phenomenal. I've never done this before. That is as long as your code's working. Here we go. Look at that. So now we have, this is what I was talking about. We have this metric is on the training data and this metric is on the validation. So see how quickly our accuracy is improving? Now I told you, epochs are going to speed up. Look at that. The first one took about 5 minutes, but these are taking 5 seconds. We're already at 1.0 accuracy. That's 100% accuracy on the training data. That is insane. So what this is telling us actually is it's a good thing. Our model is overfitting because it's performing way better on the training data than it is on the validation data. But this is great. Our model is working. It's finding patterns. It's using what MobileNet v2 has learned in ImageNet, and it's applying it to our dogs data set. Dog vision is coming to life. Oh, I'm so stoked. Now, I hope yours is running like this as well, because we're training a model together in real time. This is beautiful. So what we should see is once the validation accuracy stops improving for a number of epochs, so 3, because of our early stopping callback, it's going to stop training. So I don't think we'll reach the 100 epochs, maybe not even close. Because see here, we're getting 1.0 accuracy with a tiny loss on our training data. So here we go. It stopped. Whew. My heart is racing. That was phenomenal. So see what I meant? The first epoch takes a while because it's loading data into memory. Once it's loaded that initial data in the memory, the GPU is just going to go, all right, time to step on the gas and we'll turn on the afterburners. All gas, no brakes, baby. So we reached 18 out of 100 epochs, and we can see that our model on our training data set is performing at 100% accuracy. That's pretty crazy. 1.0. You've got to times this number by 100. The loss is fairly low. I mean, a loss of 0 is perfect. But we can tell that our model is overfitting because it's performing way better on the training data than it is on the validation data. So if we come back, it's like our model has memorized the course materials rather than the problem-solving principles of those course materials, and it's struggling to adapt to a data set it hasn't seen before, aka a practice exam or our validation set. So right now our model has a poor ability to generalize. Whew. So I think that's enough for one video. That's a lot of excitement. What I want you to do, a little bit of homework, is before we go and check the TensorBoard logs in the next video, because we've used our TensorBoard callback before, I want you to check out, this is a question, this is a really important one. After we've trained a model, I want you to go, question, it looks like our model is overfitting because it's performing far better on the training data set than the validation data set. What are some ways to prevent model overfitting in deep learning neural networks? So we'll turn that into Markdown. That's a question I want you to look up before we get into the next video. What are some ways to prevent model overfitting in deep neural networks? So check that out. Even if you're not sure of them, I just want you to start getting curious about what's going on. And I want you to start picking up on the clues as to when your model is overfitting, such as performing far better on the training data set than the validation data set. And a little note here, overfitting to begin with is a good thing. It means our model is learning. So that I'm phenomenally excited that we have just trained our first deep learning neural network together using transfer learning. Dog vision is coming to life. So we finished training a model, at least a first subset of a model. This is not on the full data. This is only on 1,000 images. So our next step is to, if we come into our keynote, what are we up to? So we fit the model to the data. We haven't made a prediction yet. So what we might do is evaluate the model using our TensorBoard callback, so you can see that. And then we'll figure out how to make a prediction with our trained model. Sound like a plan? So check out this question, and I'll see you in the next video.